common steering faults and wheels alignment. At the end of this topic, you will be able to identify the common steering problems, their symptoms, causes, and remedies. Describe wheel alignment. List the principles of wheel alignment. Detect and correct the wheel alignment problems. Importance of wheel alignment. At times, while driving a car, the front wheel may start wobbling. It in turn results in difficulty while steering. This is called hard steering. This can be corrected by following the wheel alignment principles carried out in a workshop. This topic deals with the reasons behind these problems, causes, principles of wheel alignment, and their application in a workshop. Let us discuss them in detail. Steering problems, symptoms, causes, and remedies. Hard steering occurs when the pressurized hydraulic fluid in the steering system gets contaminated, causing leaks in hoses or even complete failure of the steering system. You can prevent it by either changing the fluid periodically or getting the mechanical system repaired. There are other possible causes, such as friction in steering linkage, low or uneven tire pressure, bent body or frame. Factors like improper tire wear, vehicle pulling to one side, steering kickback. The mentioned factors has to be addressed to ensure safer driving. Let's see these factors, their possible causes, and corrective measures that can be applied in detail. Improper tire wear. One fundamental reason why the steering failure occurs is when the tires in the vehicle wear out unequally. It will lead to vibration in the steering wheel. In an automobile, the front wheel tires wear faster than the rear ones. This is because the weight of the vehicle is higher in the front. It can be prevented by tire rotation. For example, during tire rotation, take out the worn-out front tire and swap it with the rear tire so that the worn-out tire can be used for a few more rides. The other causes of tire wear are under and over inflation. These can be corrected by inflating and deflating the tires to recommended pressure levels regularly. Steering pulls to one side. One other common problem in steering is when the vehicle tends to pull across one side on its own. This occurs when the tire suspension system is broken or loosened. In this case, the suspension should either be replaced or repaired so that the vehicle travels in a straight path. Steering kickback. In the case of a reversible type steering system, an unwanted steering kickback can be felt oftentimes when a vehicle passes over a speed bump or pothole. Sometimes, the kickback may be severe inside the vehicle cabin, even on smoother roads. It might be because of the inability of shock absorbers to absorb shocks. In such a case, it is recommended to adjust or replace the defective shock absorbers. So far, we have seen the defects and remedies for steering problems. A periodical maintenance can keep the vehicle clear from a number of steering problems. Now, let us discuss about wheel alignment. So, what exactly are the components of a car that need frequent maintenance? As we're dealing with steering, we focus on checking wheel alignment. When you look at the wheels, they may seem properly aligned. In reality, though, they may be inclined. To determine this, you need to consider several minute aspects. This is where the knowledge of wheel alignment techniques comes in handy. Becoming familiar with these techniques will be greatly beneficial. Principles of wheel alignment. Adjustments are made inside the wheel assembly to ensure efficient and safe driving. Following are the principles involved in attaining proper wheel alignment: toe in and toe out, positive and negative camber angles, positive and negative caster angles, chassis height, steering axis inclination, and turning radius. Toe in and toe out. Toe is an angle that can be measured from the top of the vehicle by drawing a line through the horizontal center of each wheel relative to the central line of the vehicle. When both the front wheels are in line, there will be zero toe. If wheels face towards each other, it is toe in. If they facing outwards to each other, it is toe out. Correct toe angles improve tire life. Positive and negative camber angles. It is the degree of tilt of the wheel measured from the front side of the vehicle. A wheel tilted in, that is, towards the engine, is called the negative camber angle, while the wheel tilted out is called the positive camber angle. Correct wheel camber improves tire life and stability and reduces stress on suspension parts. Positive and negative caster angles. The caster angle is the angle between the lines drawn through the steering axis and the vertical line when viewed from the sides of a vehicle. If the axis is tilted back at the top, the angle is positive caster. If it is tilted forward, then it is called negative caster. The caster angle improves stability and enhances cornering. Chassis height. Often, vehicle owners get the height of their vehicle chassis increased for greater road clearance. It may prove counterproductive for tire life if the chassis height doesn't meet manufacturer's specification. The reason is, altering the height doesn't only change the height of the vehicle, it does alter the toe, caster, and camber angles. If the chassis height is out of specification, it can contribute to poor handling of the vehicle and tire wear. Steering axis inclination. It is also known as kingpin inclination. It helps wheels to return to the straight ahead position when carrying load. It also improves stability under braking conditions. Similar to the camber angle, steering axis inclination is measured from the front. Turning radius. While taking a curve, the steering arms enable the front wheels to turn at different angles. If both wheels turn at the same angle, the outer wheel suffers severe wear. In order to avoid this, the turning radius of the inner wheel must always be greater than that of the outer wheel. So far, we have discussed the principles of wheel alignment and various types of steering angles to be maintained by horizontal and vertical adjustments. You may want to learn how they are done. Let's see them in the following screens. Detect and correct wheel alignment. Computers have revolutionized the way industrial processes are performed. Wheel alignment is no exception. They have really taken the complexity out of everything. For example, tire maintenance has become very simple after automating certain procedures with the help of computers. The vehicle is brought inside the workshop. The vehicle is moved forward and backward until making sure that the wheels are properly positioned over the turntable. The sensor holders are then attached to the rims of all four wheels. Once the sensor holders are placed on the respective wheels, the sensor holders transfer the measured values to the computerized system. It has a set of procedures to ensure that proper wheel alignment has been made. The computer now displays the values for caster, camber, toe readings, etc. The caster camber gauge and turning radius gauge can be adjusted to vary the camber caster angle and turning radius angle respectively. Install and level all targets. The first and foremost step in computerized wheel alignment is adjusting the wheels. To do this, the caster camber gauge can be tilted until the optimal readings are achieved on all four wheels of the vehicle. To confirm this, the color of the target indicator turns from red to green. Install the steer wheel holder. Once the initial steps are over, lock the vehicle movement by applying the handbrake. Then, adjust the steering wheel until the reading measures 0 degrees and 0 minutes. It can be achieved by rotating the steering wheel. Once the steering calibration is successful, it is necessary to lock the steering wheel using the steering wheel lock. Release the handbrake and press the F3 button on the physical keyboard to start measuring. During measuring, the vehicle shouldn't be disturbed by any foreign sources. Ensure that it stays still. To ensure the proper positioning of the vehicle, perform the following steps. Push the vehicle backwards until the reading shows 100%. Similarly, push the vehicle forward until the reading shows 0%. Now, engage the handbrake on, unlock the turntable, keep the vehicle still, and press F3 for measuring. After completing the wheel alignment procedures, the handbrakes can be released. Steering wheel lock removed, and vehicle taken out of the workshop. This sums up the typical wheel alignment procedures performed in an automotive workshop. Summary. In this topic, you have learned about the symptoms of steering problems and their possible causes and remedies, importance of wheel alignment, principles of wheel alignment, procedures for detecting and correcting wheel alignment problems.